Thanks for Dongxu's excellent presentation. This is Yixuan Miao, Senior Database Kernel Engineer from Alibaba Cloud. Next, I will share why top enterprises choose ApsaraDB for MongoDB 8.0. There are 5 parts in this session. This will help you to understand the new update of MongoDB 8.0, also the advantages and pros Alibaba Cloud can offer to enterprises. Finally, we'll get you how to migrate your data to MongoDB 8.0 at a lower cost. So let's get started. First, Alibaba Cloud and MongoDB's partnership build. At present, Alibaba Cloud is the only cloud service provider in China that can offer the latest version of MongoDB. In recent years, versions 6.0, 7.0, and 8.0 have included many new features and solved many pain points. You can experience all of them on Alibaba Cloud at first hand. At the same time, we also have regular communication and cooperative constructions with MongoDB development team and the NTSC team. Whether it's kernel requirements or performance issues, we will promote the resolution in the most efficient and direct way. Of course, we also collaborate with the expert service team to provide close support to customers, delving into business scenarios to help you use the MongoDB database more professionally. As we reflect on the journey from 2019 to today, we can observe how the partnership between Alibaba Cloud and MongoDB has fostered remarkable advancements in the ApsaraDB for MongoDB service. Since 2019, not only have we witnessed significant enhancements in MongoDB's core capabilities, but Alibaba Cloud ApsaraDB for MongoDB has also iteratively introduced many practical features that cater to diverse user needs. Our commitment to understanding and addressing the specific demands of various businesses has been central to our approach. We strive to walk in our customers' shoes, ensuring that our kernel and cloud-native resource management solutions are designed with your requirements in mind. This focus empowers you to use our products with confidence, knowing that they are tailored to meet real-world challenges. Secondly, let's take a look at some of the key new features in MongoDB 8.0. First, about performance. The first part is replication speed optimization. The last time the logic here was modified was in version 4.4. Previously, the secondary actively sent requests to the primary, but now the primary continuously sends uploads through string replication, and then secondary reads them in batches with multi-threads. Version 8.0 has been further optimized. It has broken down the replay actions from the secondary node and logically divided them into 2 types of thread, writer and applier. The writer is responsible for receiving changes synchronized from the primary node, writing them into the local uplog, and pushing them to the applier thread. After the applier thread receives it, it asynchronously replaces these changes, and only then is this batch of replication truly completed. This change effectively enhances the replication capability of the secondary node under high workload, avoiding increased replication lag that would cause the secondary node to enter the recovering state. Of course, this change has also contributed to the performance improvement of majority writes. Starting from MongoDB 5.0, the default write concern has changed from 1 to majority to increase reliability. However, to some extent, performance under high concurrency has also been sacrificed. Now, majority writes no longer wait for the node to fully replay the upload before returning successfully. Instead, they directly return after writing the local upload from the node's writer thread. eliminating the time for the applier thread to replicate, and significantly enhancing the concurrent capability of majority writes. We did a WebSB test on ApsaraDB for MongoDB. Under all update conditions, the performance improvement of different specifications was very obvious. Compared with version 7.0, the average throughput increased by more than 15%. Other similar change is that for non-transactional patch insertions, like PyMongo's insert many method, for this kind of request, the kernel no longer generates a separate oplog for each inserted document, but places this batch of insertions into one oplog. All inserted documents have the same cluster time in the change stream events. This modification is made by avoiding the possible replication lag caused by replaying multi-oplogs from the node. Below is memory management optimization. MongoDB 8.0 introduces a new version of tcmalloc, shifting the front-end caching strategy from per thread to per CPU. In modern applications with numerous threads, the previous per-thread caching approach could lead either excessive per-thread caching accumulation or many threads with extremely small caches. Both of these two situations are not expected. By per CPU cache, MongoDB allocates a single large memory block globally, assigning each logical CPU a portion to store metadata and pointers to available objects in specific site classes. When total memory exceeds 4 GB, each CPU receives 1 GB per CPU core as its cache, effectively preventing memory fragmentation. Additionally, MongoDB introduces a new tcmalloc background thread that circles every second, dedicated to actively releasing unused memory back to the operating system by invoking release interface. The release speed is now controlled by the tcmalloc release rate parameter. This means the parameter has evolved from a predefined range of 1 to 10 with ambiguous settings to a flexible numeric value with units of bytes per second. On Alibaba Cloud, this parameter is set to 10 MB per second by default, and you can customize it via the console based on specific workload requirements. Also, the previously widely used parameter tcmalloc aggressive memory decommit is no longer takes effect. Next, let's discuss high-load management. A new concept called query shape hash has been introduced to group similar queries into the same category. This includes such as query fields, sort fields, and more. You may wonder, wasn't there already a similar concept called query hash? Yes, the previous query hash has been renamed to plain catch shape hash. The uses of these parameters is similar. Both are hex string, only the structure of the query is considered and specific values of individual fields are ignored. However, query shape hash is 64 bits, while plain catch shape hash is 8 bits, and the calculation methods are also some different. With the newly introduced setQuerySettings command, now we can configure a series of rules for specific query shape hash values. For instance, as shown in the picture, you can set to reject a certain type of inefficient query, or a query that triggers a full collection scan, helping online business recover quickly. This is actually the service rate limiting capability, directly rejecting unnecessary queries without occupying database resources. You can also use this method to specify which index should be used for certain query. The previous method of using plain catch set filter was abandoned. Compared to the older approach, the advantage of set query setting is that it creates a document in the cluster parameters collection under the config database to persist this rule, and it will not be lost due to issues such as restart. The next part is about the flexible scaling of sharding cluster. MongoDB 8.0 removes many operational restrictions. For example, the move collection command now supports moving unsharded collections without forcing them to stay on the premise shard. You can also use the unshard collection command, allows you to disable sharded for collection, redistributing its data to a specified shard. In addition, there are also some changes in usage. For instance, some query conditions for writing commands do not have to add all shard keys. And by default, hash sharding creates one chunk by default. MongoDB 8.0 also optimizes the reshard operation by introducing the false distribution option, which enables resharding with the same shard key. If the system is in a downtime maintenance phase, the commit reshard collection command can be used in advance to block writes, helping to faster the resharding process. The last part is about safety and stability. Query encryption now has more support and can use 4 types of range queries. The default max time MS parameter has also been added on the server side, supporting the setting of default timeout for the completion of a single read operation. Its function is the same as the max time MS specified by the client, but the priority of the client is higher. In addition, DDL operations have also been optimized, allowing for concurrent execution of DDL operations for different collections under the same database. And the error reporting speed of index construction is faster, and the fault recovery ability is stronger. For the compact command, restrictions have been added to prevent multiple compaction operations from being executed simultaneously on the same collection. Next, let's take a look at what other highlights and features of ApsaraDB for MongoDB on Alibaba Cloud. Let's first examine the overall architecture of cloud-native MongoDB on Alibaba Cloud. We deploy database instance based on resource pooling of ECS and block storage, ensuring the full life cycle is managed entirely on Alibaba Cloud, with high availability provided throughout the process. To meet diverse customer needs, we offer management capabilities such as cloud disk encryption, backup and recovery, and data migration, as well as kernel-level features like circle throttling, index recommendation, and data archiving. In terms of availability, in addition to native Raft consensus protocol, Alibaba Cloud MongoDB has a dedicated high availability component on the control plane. This component continuously performs health check and intervenes when necessary to help the instance recover quickly. Clients can use high availability connect strings or SRV records to minimize the impact of failures. Data center outage is inevitable in practice, and many customers prioritize disaster recovery capability. We offer 3 available zones deployment to further enhance instance reliability. For regions with only 2 zones, we can also provide a customized non-standard solution, ensuring continuous availability of customer service and uninterrupted business continuity. Of course, Elasticity is a key factor for customers when choosing cloud service, enabling rapid scaling up or down during sudden traffic peaks or data growth. Alibaba Cloud employs a compute storage separation architecture. Compute resource is upgraded through rolling upgrade, minimizing business impact. Storage resource supports online scaling, ensuring speed and efficiency. This approach enables faster and more flexible operations while also helping to reduce costs. The next section is about backup and recovery, one of the most critical capabilities in cloud environments, and the core way to ensure that business can be restored in times of crisis. First and most fundamentally, utilize the snapshot capability of the cloud disk to perform a full backup. The duration of the next backup is only affected by the size of incremental data between two backups. There will no longer be a situation where each backup takes a very long time, such as in physical or logical backup, and the kernel no need to return checkpoint data for a long time. Then we also support advanced features such as high-frequency backup, second-level backup, and offsite backup, meeting the backup needs of various scenarios. With the snapshot, we can carry out the recovery, create a new instance based on the snapshot backup site, and then replace the incremental uploads according to the specific recovery time point to achieve recovery capability accurate to the second level. Compared with physical backup recovery, the time consumption of recovery operation is also significantly reduced. Additionally, if full data restoration is not required, we also support multi-granularity recovery operations at the database, table, and row levels. For example, by filtering upload based on collection names and specifying collection for physical copy, followed by dynamic loading, the overall collection recovery speed can be improved by over 9 times. Further, there is a key flashback, that is row-level recovery. By leveraging the ability of storage engine to retain snapshot history records, we offer the recovery of a certain document to the original instance at a specified time points in minutes, which is faster and simpler to operate. In terms of operations and maintenance, we provide a range of intelligent tools, including real-time monitoring, audit log, session management, and storage analysis, among other practical features. These tools help DBA to quickly identify issues such as CPU spike, storage fragmentation, or unbalanced data distribution, enabling more efficient troubleshooting and resolution of problems in the instance. In addition, in version 5.0 and above, we provide more granular throttling capability. Unlike the official MongoDB 8.0 version, which can only reject certain types of queries, our solution allows throttling based on CRUD operation types and collection names. This enables precise control over the concurrency level for specific operations on a given collection. This ensures that the core business is not affected by newly launched business or sudden traffic, which could cause damage to the entire instance. Now, let's take a look at some specific cases of how leading enterprises leverage MongoDB. First of all, one of our largest customer groups is the gaming industry. The natural schema-free capability of MongoDB provides great convenience for the storage of game attribution, equipment, maps, and so on. During business growth periods, increased traffic and data volume growth frequency occur. On the cloud, these pain points can be resolved within minutes. Additionally, we offer automatic failover and disaster recovery capability for data centers. Once a version update bug or external intrusion occurs, it can most conveniently utilize backup recovery to quickly restore the business to a normal operating state. The time series collection launched since MongoDB 5.0 can perfectly adapt to the IoT scenarios, conveniently store data generated in different time periods, and significantly optimize access performance through bucketed storage and pre-sorting mechanism. The use of sharding clusters can support the storage of massive amounts of data and extremely high concurrent access. Even if capacity needs to be increased later, there is no impact of business at all. In addition, MongoDB also has 2D sphere index that support geographical location queries. You can use it to determine points within an area, calculate proximity to a point, or return exact matches on coordinate queries. For instance, in the case of shard mobility service, using $geoneer can conveniently and effectively filter scenarios where vehicles are parked within a certain range. Recently, AI industry has also been developing rapidly. Through RAG technology, chatbots have been more professional. MongoDB also has a vector capability which can store data after embedding and conduct similarity search. The search function is seamlessly integrated with MongoDB query syntax, reducing learning costs and accelerating the implementation of AI applications. Minimix AI is a Chinese artificial intelligence startup specializing in generative AI technology, similar to OpenAI's ChatGPT, which have both domestic and foreign customers. Partner with MongoDB Professional Service to smoothly migrate more than 30 TB business data from DynamDB and DocumentDB to Alibaba Cloud ApsaraDB for MongoDB. Yixuan Technology is a financial technology company which is focusing bringing financial empowerment to Southeast Asia. Also, partner with MongoDB Professional Service to replace backend database of risk control system from DynamoDB to Alibaba Cloud ApsaraDB for MongoDB. Now, let's take a look at how to seamlessly migrate data to Alibaba Cloud ApsaraDB for MongoDB. Of course, if your instance is already version 7.0 of ApsaraDB for MongoDB, you can directly click on Upgrade Major Version in the console. In this way, your instance will automatically be upgraded to the newer version 8.0. We strongly recommend using Alibaba Cloud DTS for data migration, which supports schema migration, full and incremental synchronization, and final data validation to ensure data is fully and securely transferred. Of course, you can also use migration tools like MongoDump or Namecheck. After establishing network connectivity, data can be manually migrated through the connection tree. Compared with version 7.0, there are no particular significant incompatibilities in usage. Some parameters and commands have slight changes, which have been mentioned in the previous section. There are also some limitations of corner case. More content can be queried on the official release note website. To allow more users to experience the powerful capabilities of Alibaba Cloud ApsaraDB for MongoDB 8.0, we are offering a free trial for the first month of the 8.0 version to new users. Seize this opportunity to experience the performance improvements and cloud-native optimization of MongoDB 8.0 and inject new momentum to your business. That concludes my presentation for today. Thank you.